Unit 3, Lesson 1, so review of exponents to get us ready for exponentials and log functions, okay? So let's just review exponent laws. First thing is you got to know how to identify an exponent. So identifying an exponent, you have a base, okay, right there. You have an exponent, and then the whole thing is called a power, okay? So a base with an exponent, that whole thing is called a power. Just like with a radical, you have a radicand, an index, the whole thing is called a radical, okay? So product law, let's just so you remembers. xm times xn, how do you find that? What is the property there for exponents? Add them, correct. You add them. So it's xm plus n, okay? The quotient law, then conversely, if it's x divided by xn, you minus them, good? Power of a power, multiply. So m, you can put like a dot in or just mn's fine. I just put the dot so you can see multiply. Okay, power of a product. A lot of you guys are messing this up on your review. A couple of you guys messed up on the Unit 1 review. Okay, power of a product. How does the exponent distribute? Goes to both. It has to be xm, ym. Okay, a lot of you guys are just hitting the variable, not the number. Power of a quotient, how does that work? Both xm, ym. Doesn't matter in terms of mathematically, but a lot of times they're talking about like a variable over a number. But if it was 6 divided by 3, you would get the same answer if you did it or not. Does that make sense? So it's not really necessary. Okay, integral exponents. As soon as you see integral, you're thinking integer kind of. So that means negative exponents. The thing with negative exponents is they push them down, okay, or vice versa. If you have a negative exponent on the bottom, you push it up and make it positive. If you have a negative exponent on the top, you push it down and make it positive. So I kind of get the answer for this one. X to the negative m, if you want to write that with a positive exponent, it's now down here. 1 over x to the m. That's why it says where x can't be 0, right? Because x can't be 0 because we have 0 on the bottom, can't divide by 0. Okay. Did this one in Math 10 is a very difficult part of exponents in Math 10. I remember we did those fractional exponents, remember? So how does that work? X to the m over n, okay, is the same as n x to the m. So essentially, if you want to write a little note here, this right here is the index, and this is what you're doing to it. This is the power number, or the, let's say, exponent. Let's stay with the same terminology here. See what I mean? N's the index, m's the power. Okay. Sure. No, it's fine. Or the whole thing to the m. Those are the same thing. Yep, not a problem, not a problem. Okay, and then through these examples, we're just going to go do some exponent work here with the following stuff as review. So a lot of these things you've done before. Okay, so the directions for example 1 say write without brackets and positive exponents. So if I have 1/2 y to the negative 6, that would be 1 over 2 y to the 6th. The y to the 6th gets pushed down with the 2. Okay, so that's how it makes it a positive exponent. Okay, so question. You see that x is -3 and y is -2, so those are going to switch spots, right? You see what I'm saying? They're both negative, so they're both going to switch. Well, the question I have is, where's the 5 going? Staying on the top. Very good, Ollie. The 5 does not have a negative exponent. Okay? This 5 is a 5 to the 1. It does not have a negative 3. Now, if it was in brackets, then you'd move the whole thing. Okay, but it's not. The negative 3 is only on the x. So you'd write like this. Okay, good. All right, so no brackets. So that means we need to go ahead and do that multiplication to get rid of the brackets. So this is a product. So I kind of say when you're doing this stuff, you're not really distributing. You're multiplying like terms to make one big term. So 4 times 2 is 8. X3 times x negative 4, 3 plus negative 4, right? Negative 1. Y1 times y2 is y3. So that means what's going to happen? X goes to the bottom. Yep. 8 y3 over x. You don't have to write x1. You can if you want. Okay? Yeah, we're on page 159. Cool.
How did you get y3?
Y3? Yeah. Y1 and a y2, so 1 plus 2. Yep. Okay, good. Any other questions here? So a lot of this stuff is just kind of arithmetic, right? It's just knowing the rules. It's just adding, subtracting, doing those things, knowing the rules in the right order, okay? All right, so 24. Like this one right here is already set up for you. So I'm going to divide the number, divide the m's, the p's, the q's, and then see what's left. Okay? So for example, 24 divided by negative 4 is a negative 6. Now where is that at? It's technically on top because it's negative 6 over 1. You don't have to write the 1 though. Now here we go. M5 over M4. So we do what with the exponents? Subtract. So it's 5 minus 4, which is 1. So we leave it on top because it's positive. Negative 3 minus 2. Negative 5. So that means I put a positive 5 where? The bottom. So that we go P5 on the bottom. Okay, since it's a negative 5, that just means a positive 5 is on bottom. Integer stuff there. Here's a tricky one. 4 minus a negative 2. 6, it's positive 2, right? So that means it's going to be P6, or sorry, Q6 is up. And that's your answer right there. Okay, this is talking about right here the power of a product. Power of product. So this cube is going to hit all 3 of these. So you're going to have 3 cubed, which is 27. And then it's power to power with these, so that's going to be x to the 6th, y to the 9th. And that's it. Okay. All right, so the last one with this section, we just have just examples the next page, and then we're done with the first lesson. All right, F, let's just do the easy part first. 12 divided by 3, easy enough, is just a 4, and that's on top technically. We have a b to the negative 1/2 over a b to the 1. So it's negative 1/2 minus 1. Okay, negative 1/2 minus 1, so it's negative 3/2, which means I have b to the 3/2 down here. Okay, just for practice, it didn't ask us to do this, but if I want to write this as not as a fraction exponent, it would look like this. It'd be the square root of b cubed. Be the square root of b cubed, right? It's 2. You can write it 2, but they won't. You can write it 2 there. Sorry, no, it's small. But that's what it is if you write with the radical. Okay, didn't ask you to do that, though, just so you know. All right, second page and last page for the first lesson, okay? All right, actually, let's go ahead. I'm going to pause it. I want you to try those 2. Try those 2. We'll do a quick self-check. Actually, let's do both sections, okay? Let's do both sections. Again, I'm fine with wrong answers. Okay, wrong answer is how we correct ourselves. Okay, so let's go around here. So we're going to go, Andy's going to do this one. He's going to give us the answer, right or wrong. Keegan will give me this one. Let's go with Manyang for this one. Cassie. Spicer, and we'll just go Lauren too right here. We'll get the girls up front. Okay, so you guys just give me those ones when you have them, and we'll come back here in a second. All right, again, wrong answers are cool. Don't worry about it. Andy, what'd you get for yours? 1 over 64. Okay. Okay, let's check that out. So he's got y to the 6 on top, 64, x cubed on bottom. So the -3 distributes, it hits all three. 4 to the -3, x to the -3, and then y to the +6, because -2 times the -3. So I'm liking what Andy has so far because this is on top. Yep. That moved down. Yep. 4 to -3 is 64 on bottom. Perfect. So that is correct. Okay, that's good. All right. What we got, Keegan? Did you get that worked out? Okay, so Keegan's problem when he asked me to start was he didn't know what to do with the -2. The -2 has to hit everything. All terms. Okay, 3 to the -2, x to the -6, 4 to the -2, y to the 4. Now we got to do our moving. So simply, you can see, essentially everything on top is going where? Down, and this 4 -2 is going up. So I'm going to have 16 on top for 4 squared. I'm going to have 9 on bottom. The 3 squared came down. I'm going to have x6, y4. And that's it. 16 over 9x6, y4. Okay, any questions? Okay. Okay, and like I was just telling Cole, it's like, I'm serious, if this lesson's super hard and you're super lost, you need to address that immediately. If you don't feel comfortable doing it now, you should be having questions in your dash notebook, okay, and you should be asking those questions immediately, okay? This right here, this section, I expect this workbook problem should all be done because you need to be solid with this, or else you can't solve logs, or else you're not going to be able to solve exponents, okay? So I'm just trying to make sure you know that's important. All right, so then Ollie, wait, no, who had A, sorry? Manying, what was A? You got negative, what? -8? So remember, this just means you move it down. So does it make it a negative value? Okay, it's going to be 1 over 2 cubed, which is 1 over 8. Now, if you had this, 8 to the -1, that's technically the same thing, but just remember, that's not a negative value. Okay? So it says determine exact value of the following, verify with the calculator. That's the exact value, 1 over 8. Okay, that means you're not putting the decimal, you're not rounding. Okay? Everybody got that? So then 81 to the 3/4. Okay, how about that one? Cassie? 27. Okay, so she got 27, so let's see how we can get there. So remember, this means 81 4th rooted and then cubed. Well, 81 4th rooted is 3. 81 4th rooted is 3. So then you have 3 cubed, which is 27. So she's right. Okay. You can do it either way, too. You can do 81 cubed and 4th root that, and you'll still get 27. Okay, that's why those two ways that we put in the beginning are still good. No work to be done here, really, Spicer? Do you know what anything to the 0 power is? Nope. 1. Anything 0 power is 1. Okay, pay attention because everybody puts 0. Okay, this is why it's not 0. Okay, we know we'll use division of exponents to prove it. We know that if I have 3 squared over 3 squared, that's 9 over 9, which equals 1, right? Now, if I go this way, what are we supposed to do with exponents? 2 minus 2. What's 2 minus 2? 0. That's why it's 1, not 0. Okay? It is not 0. Okay? It happens all the time. Okay? Cool. All right. 16 to the -1/2, which also means 1. Now, I want to read this a different way, see if you can hear me. 16 to the -1/2 is also 1 over square root 16. Right? Move it down, 1/2 of something's square root. Okay? So just saying that, you can be like, oh, it's 1/4. Okay? All right. What did we get? 1/4. Good job. Okay? A lot of pressure. Okay? So it's 1/4. So we can do it like this. It's going to be 1 over 16 to the 1/2 16 to 1/2 means square root 16, which is 4. Okay, perfect. All right, we're going to change base, and then we're going to move on to lesson 2 in a second. You guys are doing good today. Not bad for a Monday. Okay, so convert each of the following to base indicated. Now, this is a very a useful strategy because a lot of times you'll see answers on diploma or an answer on a test. You're like, that answer's not there. I don't have anything like this. Think about, can I change the base? Okay, can I change the base? They do this quite a bit in SAT too. I remember I used to miss these because I'd be like, there's nothing with a base 3 here. Okay, and so you got to kind of think about it. So for example, change this to a base of 3. So how can you write 9 in terms of a base of 3? Close. 3 squared, not square root, but yeah, I know what you meant. It's 3 squared, right? That's how you write 9. And then what's up there right now? 2x. And so then, sorry, we're going to have the 2x here as well. I put a dot there for now, but what's that going to be? Right, it's going to be a 4x because we changed this 9 to 3 to 2x, so it is a kind of a power to power situation. So it's going to be 3 to the 4x. Okay, this is important for solving. Changing the base. 125. What would you change 125's base to? A base of 5, it says. 5 to the third. And so maybe we'll write it like this. Whoops, sorry, I don't want the x there. Let's erase this real quick. It's going to be 2 minus x. So what do you have to do there? Got to distribute. Good. Distribute the 3. So it's going to be 5, 6 minus 3x. You can put a bracket here so you know it's all an exponent if you want, but 5 to the 6 minus 3x. Okay. I'll just give you a spoiler alert here. The reason you can change base sometimes, because if you have two things to the same base, for example, if I said you had 5 to the 6 minus 3x equals 5 to the 4th, you have an easy algebra problem now. You set these equal to each other. Because they have the same base, that means the exponents you can set equal. That's what we're getting to. Okay? You don't have to worry about that now. Exactly. When you have them the same, you can drop the base, and you can just solve that top piece. Yeah. Okay. 8 times 16, it's all of it at a base of 2. So let's do it piece by piece. What is 8 as a base of 2? 2 cubed. Good. What is 16? It's just the next one, right? 2 to the 4th, and then times x. So you have 2 cubed times 2 to the 4x. So how do you write that? We don't multiply them now, right? Right. It's 2, 3 plus 4x. You add them by exponent rules. Okay, you add them by exponent rules. Okay, good. So a lot of this stuff shaking the cobwebs a bit. Okay, good. Now this is a tricky one. Okay, it's 1 over 512 to the 3x. 1 over 512 to the 3x. So let's look at 512s. Well, what's 512s with a base of 2? Anybody figure that out for me real quick? 9. Good. So it's 1 over 2 to the 9th. Close. With a 3x there. It didn't say to write it as a positive or negative, Aiden, so you can leave it down there or write as a negative. I would be fine. But yes, it's going to be 1 over 2 to the 27x or 2 to the negative 27x. You can write it either way. So I got 27 from 9 times 3. If you're like, how'd you get 27? We times the 9 and the 3 there. We got the 9 from Aiden. Aiden said 2 to the 9th is 512. Okay. And we're good here. Okay, lastly, they want to make this a base of 2/3, so we want to change the 16 to a power of a base of 2 and the 81 to a base of 3. They're both 2 to the 4th and 3 to the 4th. Does that make sense? So since they're both 2 to the 4th and 3 to the 4th, that means I can extract a 4, right? Because the 4 hit top and bottom. So I can put a 4 out here. And then your final answer would be 4x plus 20.